Welcome to a continuation of Lesson 1.1, the number line. Today we are looking at fractions and decimals and some whole numbers and comparisons. And again, we could use the number line to help us with this. If you remember back to your notes today, we ran into a little bit of trouble using just number lines for this method. It might require you to draw quite a few sketches and quite a few divisions of parts to compare some numbers that are pretty close. So for that reason, we are going to accept the idea of using other types of reasoning. So if you can show your work in some other way that, again, demonstrates your understanding of place value or your demonstration of the comparison, it will be accepted. This starts on page 3 of your homework assignment, your extra practice from lesson 1.1. If you look at this section, it says, fill in each box with greater than or less than. Use a number line to help you. Well, if I look at number 11, I definitely can picture a quick sketch of a number line. This would not take me too long to realize that if I'm moving along the number line, 103 is going to happen before 301. So 103 is farther to the left, 301 is farther to the right. Well, if you remember, left is less. So in this situation, I would draw the less than symbol. Another way, without drawing that number line, would be to quickly show me the hundreds place determined who had more. Let's take a look at number 12. This is another example with whole numbers, but in this case I notice that the 2 is the same in the hundreds place. So I move over another place value and I notice that in the tens place I either have 4 tens or 1 10. Well, obviously 4 tens would be a better situation or more than 1 10. So I'm going to use the greater than symbol. So again, some quick notation without the number line would be to show me the place value that determines the larger quantity or amount. Number 13 gets a little bit trickier because now they're introducing two fractions being compared. Number 14 does the same. And when you notice, our fractions do not share the same denominator. What I'd like to see you do, instead of splitting a number line into fifths and another number line into sixths and getting really, really close in a comparison that might be difficult to view or to make accurately or precisely, we can consider making equivalent fractions. So I want you to look at these denominators of 5 and 6. Is there a number, a multiple, that they both share? Could I multiply 5 and 6 to the same number? I'm going to show you a quick listing strategy that would work. If you list your multiples of 5 and then your multiples of 6, we should be able to find a common denominator. Well, counting by 5s, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, 5 times 6 is 30, 5 times 7 is 35. I'm going to stop here and see how things go. Let's now try counting by sixes. So this is just like skip counting that you used to do in the elementary school. 6 plus 6 is 12, and 12 plus 6 is, etc. But I'm going to try just thinking of my multiples by saying 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Oh, 24 and 25 are pretty close, weren't they? Let's try again. 6 times 5 is 30. If you notice, we just found a win. We just found the least common multiple. We just found the number that we can turn both of these denominators into to have the same size pieces or parts. So how did I go from 5 to 30? From fifths to 30ths? Well, I could go down my list here and look and say, well, that was the first, second, third, fourth, fifth, sixth multiple. I must have multiplied this by 6. Then, if you remember, we need to use the same rule in the numerator. What you do to the bottom number, you must do to the top. We keep the fractions fair. So 3 times 6 gets me 18. Please don't forget to give me your whole number. That has not changed. We still have 5, but instead of 3/5, we've cut it into smaller pieces. We have 18/30ths. Let's try the same idea with the 5 and 5/6. We want to change our 6 into 30ths. To do that, I'm going to have to multiply. I'm making more pieces. So I'm going to look at my multiples of 6 and count over 1, 2, 3, 4, 5. Oh, that must be 6 times 5 gets me 30. And what we do to the bottom of our fraction, we do to the top. We treat numerators and denominators fairly. So what is 5 times 5? Hopefully you'd say 25, and you would have 5 and 25/30ths on the right. Is it possible to compare now? Of course it is. If you notice, we have the same whole numbers and the same denominators. So really, the deciding factor here is who has more pieces or parts. Is 18 greater than or less than 25? Hopefully you're recognizing that 18 is less than 25. So 5 and 18/30 is less than 5 and 25/30. And that will also make our original inequality true. Number 14 works similarly. If you look, we're given 8ths and 9ths. Well, those denominators don't match. I want you to notice for a quick minute that they have the same whole number and the same numerator. So there might be another way of handling this one. You could absolutely do your multiples of 8 and your multiples of 9 to find a common denominator. And hopefully you could find that pretty quickly, even using your multiplication chart as a tool. It might be helpful. Another way to look at this might be to notice that the numerators are matching. That wasn't true in the last problem. Here the numerators are matching. So I have 7/8 or I have 7/9. If I think about that, if I have a pizza cut into 8 parts and a different pizza cut into 9 parts, one of them has more pieces, but they're smaller. So 9ths are smaller, aren't they? I only have 7 of these smaller pieces. And if I picture a pizza cut into 8 parts, I know that 8 pieces would be a little bit bigger than 9 pieces. So if I have 7 of those little larger pieces, it would really indicate that there must be more on the left. Oh, now the pen doesn't want to cooperate. It must be tired from the day. All right, we'll try 7 and 7/8 is greater than 7 and 7/9. And our reasoning behind that is we could say 8ths are larger parts or pieces, right? That would be another way to get there. Again, you could continue this idea of your multiples until you find something that will work. It might take a little while, but you could also find common denominators. So showing you a couple different strategies that are possible here. If you can find a strategy that works for you each time, and this multiple strategy absolutely will, that might be a good way to go. Next, we're going to take a look at these decimals. If you notice, number 15 and 16 are comparing decimals to decimals. That's actually pretty nice. What it means is that I don't have to change the format a whole lot. These are similar numbers. Well, if I take a look, I notice that there's a whole number of 48 and a whole number of 48. Those are matching parts. But if I look at the back of the number, here I have 96 hundredths, and here I have 69 hundredths. So this is really where we decide which one's greater. Does this also remind a sixth grader of something that they really, really like? Money. Looks like money to me. Would you rather have $48.96 or $48.69? If you are anything like the sixth graders I know, you probably want a little more change. So using this strategy, we can identify that if it looks like money, the last 2 digits are really determining who gets more as far as their cents. Let's look at number 16. Now, I see the same numbers. I see a 7, 9, 0, and a 3, and a 9, a 7, a 3, and a 0. But there's a difference happening here. If you just dig into the whole numbers for a quick minute, these already are set up to the same place value, and they already look like money. Would you rather have $79 or $97, regardless of how much change is behind it? My guess is you would know that 97 whole dollars is bigger than 79. So if we were to read this, we'd say 79 and 3 hundredths is less than 97 and 30 hundredths. The next section gets much more challenging because if you notice, we don't just have 2 fractions to compare, or 2 mixed numbers to compare, or 2 decimals to compare, or 2 whole numbers to compare. Unlike the others that we've looked at today, we actually have a combination. For this next problem, I notice that I have a decimal and, oops, technically that's called a mixed number, not just a fraction. So let me fix that for you. And the mixed number. So I'm just thinking to myself, these don't match. Something's not the same here. Well, in class, some students tried really hard to turn their fractions into decimals. And it's possible if the denominators are the types of things like tenths, hundredths, thousandths, and so on. But I'm not sure that 7 is a very friendly denominator for decimals. So when that's the case and I don't have a good denominator to start with, I might instead choose to change my decimal to a mixed number. How do we read this decimal? That will absolutely help us to write it as a mixed number. So I would read this 6 and, when I get to the decimal, so 6 and 25 to the hundredths place. So this is 6 and 25 hundredths. Well, if I can write that as a mixed number just the way I read it, it would look like 6 and 25 hundredths. Here we have a mixed number. Well, we're really close. If you take a look, it looks to me like these both are mixed numbers now. At least that part of the problem matches. But what do you remember? What could be a problem? Oh, our denominators. Take a look. I have hundredths. Those are very tiny, and sevenths. Those are pretty big pieces. So I need to make them the same size. Maybe you notice that this fraction could be simplified. Maybe you remember doing that in 4th and 5th grade. Well, what divides nicely into 25 and 100? Maybe you notice that they both divide by 25. If I'm thinking about money, oh, we think about money a lot in this classroom, don't we? I know that both of these numbers are divisible by 25. I still have a whole number left, but 25 goes into 25 one time, and 25 goes into 100, let's think, 25, 50, 75, 100, 4 times. Now I have 6 and 1/4. Okay, I still didn't get to the same denominator, but I sure did make my number smaller, and that might be a little bit better to work with, don't you think? So now we're going to think of that idea, finding a common denominator. I'm thinking to count by 4s and count by 7s until I find the same multiple that they both share. So that would be your next step. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, 4 times 9 is 36, and so on. Let's see if we can find one now. We'll count by 7s for a minute. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28. Stop. Hold up. I noticed something. Hopefully you see it too. We have a matching number. We just found the least common multiple, a common denominator. I can turn my 6 3/7 into 28ths, and I can change my 6 1/4 into some number of 28ths. Well, the whole numbers are not going to change if you remember. I still have 6 whole pizzas out front, but that denominator, it did change, didn't it? Well, I multiplied 7 by something to get to 28. 1, 2, 3, 4. It must have been 7 times 4. So 3 times 4 in the top would get me 12 pieces or parts. Next, how did we go from 4ths to 28ths? Well, 1, 2, 3, 4, 5, 6, 7. You'll notice that that's your 7th multiple. You actually multiplied by 7. On the top and the bottom, we can get an equivalent fraction. So 1 times 7 is 7. I have 6 and 7 28ths. If you remember long ago, this decimal was on the left-hand side of my inequality, wasn't it? It traveled all the way down here into a mixed number, and then a simplified mixed number, and now an equivalent mixed number. This 6 and 7 28ths is really this value on the left. So it might be important to do a rewrite step. We'll keep it on the left here and show 6 and 12 28ths on the right. We didn't have much changing to do on the right-hand side of our inequality. Well, taking a look, the whole numbers match, the denominators match. So if you notice, it's either the 7 or the 12 that will decide. I know 6 and 7 28ths has fewer pieces, less than 6 and 12 28ths. I want you to try the same strategy with number 18. If you notice this denominator, it has an 8. That doesn't seem terribly friendly when it comes to decimals. So here we go again. I think we're going to do a rewrite step. I think we're going to take 9 and 56 hundredths and write it 9 and 56 hundredths as a mixed number in fraction form. Could we simplify this a bit? Oh yeah, I think something divides nicely into 56 and 100. You just have to figure out what it is. Maybe looking at your multiplication charts, those big charts that I gave you that go up to 30, what sort of things are you seeing? Well, they're both even, yes. Oh, I actually see them in the 4 row. They both divide by 4. Let's give that a try. So when I do that, let's see here, I have 9 is my whole number, 4 goes into 100 25 times, and 4 goes into 56, thinking about this in my head here, 14 times. I should say 14 on your charts. Right? We're really close. Here I have 8ths, here I have 25ths. Okay? At least we're a little bit closer than we were. What will I have to do as the next step? Get a common denominator. Let's be honest, some of these numbers are going to get pretty big, aren't they? If I have to multiply 8 times 25 to get to a common denominator in a minute, which I think I may have to do, you might have a really large number. And I guess that's what we're going to do today, just to show it. I think it'd be better to try this strategy than to try to draw it on a number line. So I'm thinking of 8 quarters. If I multiplied this times 8, just as a quick step to get there. 8 quarters. Well, 4 quarters is $1 or 100 cents. 4 more quarters is $2 or 200 cents. I have 200s now. And on the top, 8 times 14. Let me think. 8 times 10 is 80. 8 times 4 is 32 more. 80 plus 32. I think I'm going to get 112 pieces here, or parts. On the other side, we have to get to those crazy 200s. Oh my goodness. And if you remember, I took a shortcut on this one. I said I'm just going to multiply the two denominators times each other. I'm going to get a really huge number, but I know it will work. So this is like taking 8 times 25. So 5 times 25 on the top. Let me think about that. Let's count quarters. 25, 50, 75, 100, 125. Well, these numbers got big, but the good news is I can compare them now. I still have 9 holes no matter where I look, here or here. That 9 is the same. And I still have 200ths as my denominator. That's the same. So what's different? The numerator. It looks like 5/8 is going to be greater than 5600ths. If you notice, 5/8 is a little more than 1/2, just like 5600ths is a little more than 1/2. So it's kind of important that we get to the same format so we can compare them well. Let's go ahead and take a look at the rest of this paper and see if I can give you some other hints if you're feeling stuck. I think I'm going to let you work on number 19 and number 20, but I will caution you, the numbers could get big. If you take a look, we again have a decimal compared to a mixed number. And this mixed number, with thirds, doesn't seem very friendly. So what I would start with first is rewriting your decimal as a mixed number. If we can read this decimal, we could write it as a mixed number. So this says 3 and 7/10. That's in the tens place. So 3 and 7/10. Don't forget to find me common denominators next, and you'll be heading in the right direction. Let's take a look at number 20 real quick. Is this a friendly denominator to turn it into a decimal? I wish it was a 10, or maybe a 100, or maybe a 5, which I could turn into a 10, but it's not. So in this case, I would go to your decimal. I would rewrite it as a mixed number also. So practice reading this decimal with me. It says 10 and 57 to the hundredths place. So that's 10 and 57 over 100. Well, I know something. At least I now have mixed numbers. The bad news, they don't have the common denominator I want yet. Not yet. But I bet I could get there pretty quickly if I look back at my other examples. The last 2 problems you have for today involve arranging numbers and also putting them on a number line. And I feel like every year I have students that are super hasty. They move so quick that they miss the fact that we're supposed to make a horizontal number line. So not only are we putting these in order from least to greatest, we need a number line to go with them. And my toolbar is fighting with me a little bit. It's kind of in the way. I'm going to try it over here. All right, let's read our directions. Bold print says, read here. Arrange each set of numbers in order from least to greatest. Then draw a horizontal number line. We need to get that horizontal number line. If you don't have that drawn, you haven't completed your task. So there are 2 parts here. Step 1, arrange. Step 2, horizontal number line. Okay. This kind of helps me remember that I'm not missing any pieces. So, to represent the set of numbers, I know we're going to need a horizontal number line. Quick refresher. Horizontal, you should throw your arms up to the side and be thinking horizon, horizontal. Very good. I'm sorry, there's a bit of a wave in my number line. Hard to draw big on this board. All right. Well, before I can put these on a number line, I really want to check to see what I should use for intervals. And I'm looking at these denominators going, uh-oh, We have halves, we have sixths, we have thirds. These don't match. I wish they were all the same. Well, I bet we could make them all the same. So that's why I had these extra boxes over here. You may need some extra paper for this task. Looks like I may need some extra paper for this task. So I'll kind of park this right about here and see if we can show what we need to. All right, so for 7 1/2, 8 1/6, 7 1/3, and I see some more thirds, sixths, and sixths coming at us. I'm thinking, this is number 21 on my paper. What number will work for half or halves, sixths or sixths, and thirds? It's 3. So again, trying this multiple list. 2 times 1 is 2. 2 times 4 is 4. Oops, I said that wrong. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Let's try the sixes for a quick minute. 6 times 1 is 6. 6 times 2 is 12. You know what? I see a match here already. I wonder if we can get 3 to multiply to 6 also. So here I would test and say 3 times 1 is 3. 3 times 2 is 6. And hopefully you see it. This is the magic denominator. Okay, it's not really magical. It is pretty mathematical, but it looks pretty awesome anyway. If you ask me, I think we can turn each of these fractions or mixed numbers into 6. Let's try that. So the first fraction they give us is 7 1/2. I want to turn it into some number of 6. The next one they give me is 8 1/6. Hey, this is already 6. I don't have to change this one. Check, this one's done for you. But next I have 7 1/3. And in a minute, I'm going to have to turn that into some number of 6. And I'm going to continue this idea with each of the other fractions. I'm just going to give you a hint to get you started. So let's look here and see what we can do to show some work. How would I go from halves to 6? Oh, well, in the 2's row, I use 1, 2, 3 multiples, so we multiply by 3. If I do that to the bottom, you do that to the top. So what is 1 times 3? We'll get 3 in our numerator, and the whole number stays the same. Good. 7 3/6 is the same as 7 1/2. In fact, 1 is half of 2, like 3 is half of 6. That's a good check. This one's checked out. We're good to go. 8 1/6, we said we're going to leave alone. It has that nice denominator of 6 that we agreed on. There we go. That looks good to me. Let's try 7 1/3. How many sixths would that be? Well, I know that the whole number comes along for the ride, so I'm going to have 7 here. And 3 times 2, or if you remember, look over, 1, 2. It's the second multiple, so we multiply by 2. Gets us 6. And then using the numerator, 1 times 2, I'll get 2. 7 2/6 is the same as 7 1/3. It's just renamed. It has another identity. It's like a nickname. Okay? I want you to continue this idea, and when you're done, you should be able to tell which is the smallest of your fractions here. In fact, I notice we're done with, well, different color maybe. We're done with all of the whole numbers involving 7, right? We took care of those. So I changed 7 1/2 to 7 3/6. I can look over here at my work, and I see that. I changed 7 1/3 into 7 2/6. I can see that over here, so I'm going to rewrite it here so that I can work with that number in either form. And 7 5/6, actually, it's already set, isn't it? So let's talk. Which one of those is the smallest? 7 5/6, 7 2/6, 7 3/6. Well, 7 2/6 is the smallest, so that's going to go right here on this first line. But that's not the number they gave me to work with. They actually gave him a nickname. They called him 7 1/3. So I'm just going to show you that he has 2 identities. All right, we're done with this one. 7 1/3, also known as 7 2/6. All set, check. Who comes next? 7 5/6 or 7 3/6? We're trying to think a little bit bigger. Not the biggest, the one in the middle. Well, that would be 7 3/6. But that's not actually what they called him. He had another name. So what is he also known as? Oh, that's 7 1/2, isn't it? So I'm just listing both of his names here so that there's not confusion about where that came from. But those really represent the same mixed number. It's just in a different format. Last but not least, I know I have 7 5/6. So it looks to me like he is the third value in order from least to greatest. Now I know next I want to list my 8s. 8 1/6, 8 2/3, 8 6/6, go in some special order. But what am I going to have to do first? Find a common denominator. Remember, I can turn them all into 6. So I'm going to let you work on that, and I'm going to let you try to fill in those last three for me. I will talk to you a little bit about this number line. Let's talk. If the very smallest mixed number I'm given is 7 with a little bit of extra, what whole number is slightly under that? What whole number is slightly smaller or to the left of my number line? Hopefully you recognize it's 7. Well, I know if I'm counting on the number line along the way, I might run into 8. Well, that is true. I could run into 8 on the number line. But if I stop at 8, will I be able to fit all of these mixed numbers? The answer is no, because some of these mixed numbers have a whole number of 8 plus more. They have 8 and a 6 extra, or 8 and 2/3 extra. So next you'd move along the number line, and we probably have to include 9. Are there any mixed numbers here that go over 9? The answer would be no, not right now. So I think we have enough information to get started. Remember, what do we use for our denominators? Hopefully you say 6. We use those 6 each time for our denominators. So how many intervals should you show me between 7 and 8? 6. You should show me 6 intervals. So I'm going to try to show you that now. There. I have 1, 2, 3, 4, 5, 6 intervals. Of course, I'm going to have to start labeling them in a minute. I also need to show the same number of intervals between 8 and 9. So look at those denominators. What did we use for those denominators? The magical 6, the mathematical 6. So we're going to show 6 intervals between 8 and 9. This number line is mighty embarrassing. I know you're going to have to go back and give me some labels. So 7 plus 1 little 6 would make 7 and 1 6, and 7 plus 2 little 6 would make 7 and 2 6, etc. I want you to continue this idea, see if you can get them labeled. But even then, will your number line be complete? Not quite. What's the last step? Ah, that's right. Mr. Schumann's always looking for points. To make the point, I will write it here for you. Make sure you give me points where we need them. So, giving you a big hint here, I see 7 and 2 6 was in our list. It also has another name. He's also known as 7 and 1/3, but he needs a point. Was 7 on the list? No, so he does not need a point. Was 7 and 1/6 on the list? No, so no point for him either. I want you to continue this pattern with your labels, and then go back and make sure you have points in the right locations. We'll take a quick look at this last one. I'll see if I can scroll a little bit for us. So again, we are supposed to make a number line. We're supposed to put our numbers in order on the number line, from least to greatest, and we're also supposed to list them in order from least to greatest. So I'm looking for a number line between 3 and 5. Oh, this is a huge help to me. I could almost start the number line right now. They give me the whole numbers. They say, hey, go from 3 to 5. Okay, I will, with lots of space in between, by the way, because chances are good I might need it. So here we go, 3 to 5. Looks good. Well, I want 3.5, 4.5, 3.25, and all of these decimals to be included. Well, these all have decimal place values, and I noticed that my number line does not. I wonder if there's a way that we could put something at the back of each of these to make it look more like decimals. Well, if 3 whole pizzas is the same as 3 whole dollars, I might show you that a whole number has a decimal at the back. And if I wanted to show this to the tens place, I'd put 1 placeholder, 1 0. Or if I wanted to go to, say, the hundreds place, because these go to the hundreds place, I might show 2 zeros. I could do the same thing with 4. 4 whole dollars would look like 4 and 0 hundredths. This is looking a little bit closer to the things I need to put on my number line. For this next one, 5, well, it looks like a whole number right now. I might write it in decimal form so that it goes to the hundreds place. We're really close, aren't we? This is looking pretty nice. Now notice that some of these decimals need to be rewritten. I'm not sure that I like that this one ends in the tenths and this one ends in the hundreds. So how can I make them all look more alike? Make them at least land in the same place value. Well, hopefully you'd rewrite 3 and 50 hundredths like this, showing an extra placeholder at the back of the 5. Could I do the same thing with 4 and 5 tenths? Yeah, I could write this as 4 and 50 hundredths, right? These have the same meaning. This next one, I don't think I need to change much because these next 3 actually land in the hundreds place. All right, if you're thinking about money, I think you're ready to put these in order. Which one is worth the least? Which one do you not really want? Although someone in class told me the other day, any money is good money. Well, if I take a look, I know that $3 are the smaller amounts, and I have two to choose from. $3.50, also known as 3 and 50 hundredths, or $3.25, also known as 3 and 25 hundredths. Well, hopefully you're recognizing 3 and 25 hundredths is smaller. That comes first. That decimal is taken care of in order. Next I need 3 and 50 hundredths, also known as 3 and 5 tenths. But I think it's okay to list it this way. Next you'd have to take a look at your values that start with 4 as a whole number and decide what order they go in. And again, we're making a list, so it'd be really nice to show it as a list with commas. Now here's where we could get into a bit of trouble. Our number line, it's missing some intervals, isn't it? So I do want you to finish ordering your decimals here, but in a second we want to make sure that we have good intervals and spacing on our number line. So take a look at the backs of these. 50 hundredths, 50 hundredths, 25 hundredths, 25 hundredths, 75 hundredths. That really reminds me of quarters. If we count by 25s, we'd say 25, 50, 75, 100. Well, that also makes me think that I could split this into that many intervals, meaning quarters. That requires 4 parts. So let's go ahead and try that and see if it will work out. If I put 4 intervals, 1, 2, 3, 4, between 3 and 4, I should be able to label these and be able to include all of the decimals I need. So what's $3 plus 25 cents more? $3.25, or 3 and 25 hundredths. You know what? That was actually in my list. This one will get a point, won't it? Let's go again. What's this next stop called? Hopefully, you know 25 cents plus 25 cents gets us 50 cents. So here we are at $3.50, or 3 and 50 hundredths. Oh, hey, that's on my list also. It gets a point. Our next stop along the way, what would we call this? We had 3, 325, 350, 375. And does that need a point? Is it on my list? If I look up here, I don't see it. So it is on my number line as far as a tick mark or a location, but I'm not really going to worry about it. I'm not going to put a point because it's not in my list. I did not finish this problem for you. If you stop at this point, I say, yikes, you must be relying on Schumann for the answers. And that's not what I want. What I'd like to see you do is finish this idea of ordering your decimals, creating good intervals with labels, and giving us some solid points on the number line. So please do continue working on this assignment. Try to finish up these number lines with some good detail. They need tick marks, they need labels, they need points. This ends our lesson 1.1. Next time I see you, we'll be talking about another aspect of number sense in lesson 1.